number like this. We take the maximum number of concurrent processes, we multiply that by something. It should be the size of the largest plan that we've got. How do we find out what the largest plan is that we've got? We could run a DBCC-men usage to figure that one out. We'd add a fudge factor, we'd multiply by another fudge factor, and we'd cross our fingers. Advent of 15, because we're doing so much extra in 15, there's a lot of other space we need available in there. Histograms, sort buffers, aux buffers, subqueries. Lots of stuff is getting done in procedure cache that was not being done there before. As a result, we have a lot more space. So what is our knee-jerk reaction? Well, I don't want people screaming at me. I don't want the server crashing. What do we have before? 1 gig? Well, now we'll go for 3 gig and cross our fingers. Are we all 3 gig? Probably not. No, not. Well, we tried looking at the sysmon output. The sysmon output doesn't really tell us how much of the procedure cache we're using. It just tells us how well it's being used. How about we look at something like monitor config? Well, the monitor config will report on how the procedure cache is used. One small problem with that. When I was working with that shop that had the procedure cache system crashes going on, we spent time with Sybase engineering. Anybody want to guess what Sybase engineering told me about how reliable the cache utilization was in the monitor config? Those of you who are laughing know that they said, don't rely on it. So at that point, we have to wonder how to do this. How are we going to manage it? Here's the trick. Step 1, over-configure it. Why? Because we want to make sure that we have enough information going on. Step 2, titrate it down. And titrating it down, what you'll do is you'll watch your ST-sysmon output during your peak times and look for the out of existing plans. And when that starts to spike, you've titrated it down a bit too far, you move back in the other direction. Some will say it's more art than science being a DBA, but if you think about it, science is trial and error. So you get art with the science at the same time, right? Next tip, statement cache. With the advent of late 12.5, 12.5.4 point something, Sybase introduced the concept of statement cache. The idea behind statement cache is that we're going to take SQL statements and try to give individual SQL statements, the ad hoc SQL statements, the benefits that the stored procedures had, which is to say, we take the statement, we cache the query tree, we cache the plan, and we reuse the plans for the individual SQL statements. It's been a great idea. Well, 12.5.4, it worked out kind of cool. With the advent of 15, it's pretty critical. The reason it's pretty critical is that with 15, we have a rewritten optimizer. Optimizer gets rewritten. What does that mean? Well, it's doing 9 times more work. I'm exaggerating just a little bit, but if you've done any work with 15, what you found is that the optimizer is taking up more time. In fact, one of the things you can do with 15 is actually instruct it on a per session basis. Don't spend that much time in optimization. You're taking too long, and I'm not willing to wait for you. The idea behind statement cache is if we have the ad hoc queries, we can avoid that additional optimization step. Is that always a good thing? Well, we get to make that type of decision with the literal autoparameterization. We'll come back to this in just a second. So with statement cache, we're accommodating this. Now, one of the questions that comes up in the forums when you're starting to use statement cache is, gee, if we've got statement cache, is it really useful to do stored procedures anymore? This is worse in the Microsoft environments where you've got a lot of people who really don't get what they don't get. In Sybase environments, people tend to get what they don't get, and they tend to understand these things. There are a lot of advantages in using stored procedures. It's parsed. We already have a query tree. The code is already resident on the server. We're not passing it across the network. Lots of benefits you still get from that, in addition to the fact that we're able to pass in parameters and have those parameters treated as constants at optimization time, which you don't always get with your ad hoc queries. Stored procedure is still a good idea, even with statement cache. Now, we pose the question, is this still a good idea? Here's the case in point. I have 2 queries. Here I've got select from authors where the author ID is equal to one thing, and now I've got the exact same query, but with a different parameter passed in. The question is this the same optimization standpoint? Yeah, pretty much. Here's the thing we'd ask, though. Looking at this table, is this author ID relatively unique? Well, this is the ID out of the authors table, then yeah, I know I've got 1 or 0 of these. This is effectively the same query. But what if looking at the author ID in a titles table, where I'm saying, give me all the books for an author? I might get 1, I might get 100, I might get 1,000, I might get 1,000,000. In starting to look at these, maybe the queries are actually different. Let's take a more common type of query. Give me all the trades that have occurred in this trading system after a particular date. Well, that date is noon today. I may not have a lot of trades compared to after this date being, say, 3 months ago. I have worked on systems where we see hundreds of thousands to millions of trades in a given day. So as we're looking at this, the numbers can change dramatically. So what we will typically do is try to write queries where that's not going to vary dramatically. If it isn't vary dramatically, I want to put it in a proc and use recompile the procs. So those are happening automatically. Be aware of that as you're starting to look at these things in statement cache. With any luck, these are going to be relatively consistent. If they are, you get a big bang for the buck, is you're going to get similar performance out of your ad hoc queries that you are going to be getting out of your stored procedures. With 15, it is a very good idea to enable literal autoparameterization. This is an SP configure option. I still see a lot of shops that don't have it enabled. Just doing this can sometimes take a 10 or 15% load off your box. I explain why it's that dramatic, but I have seen the effects. Histograms. Why do those differences make such a difference? Looking at selecting from a particular table, and in one case I'm looking for dates between 1991 and 1992. That's a year's difference. The next one I'm looking for a day's difference. Well, what's going to happen here? When we use the optimizer, when we look at the optimizer is saying, I want to try to determine the fastest query path to bringing the data back. In the old days, we used to say, give me the path that used the least I/O. That's changed with parallelism. With parallelism, the optimizer says, give me the plan that gets me the result back in the least elapsed time. That's a change in behavior. Now, looking at these things, and look at the plan, what happens if we optimize based on one of these and execute based on another? That can cause some issues. But how does the optimizer make the determination? The optimizer makes that determination based on the histogram it's got internally. A combination of information, the sys statistics and the sys tab stats tables. Where it gets. But from a practical standpoint, we need to make sure those statistics are up to date because the server does not keep them up to date. Now, you've got some marketing along the lines of, hey, we can now automatically keep the statistics up to date with 15, but really there's a scheduler that comes with Sybase now that nobody knows about, but you can install it and use it. And then nobody in quotes, I know some of you are probably familiar with it, but I don't know any shops that are using it. And then there are templates within the schedule that allow you to automatically update the stats. For those of you who don't update stats a lot, some things to keep in mind. And this is something I'm actually just battling this week at a client's side. The idea behind the stats is to update our statistics, we're letting the optimizer know what the distribution of our data is. Back in the pre-11 days, we had a single page of data. That was our statistics page, and within the scope of that statistics page, whatever number of keys fit, that's the number of distribution steps we could look at. That's a little different. The number of histogram steps and the number of tuning factor steps are things that we can configure. Now, the defaults are 50 and 50. 20 and 20. So 20 steps, histogram tuning factor of 20. A little bit about what those things mean. That means with a number of histogram steps of 20, we are going to evenly divide the data into about 20 pieces and record the values at each of those 20 places. Now, what does the tuning factor do? Within the scope of the tuning factor, if I find a lot lot of data clumped around one of those numbers, I will use the tuning factor to put additional data points around that particular factor. Now, that means that if we've got 20 and 20, we've got somewhere between